Hi everyone, I am Devi Salakji from CSC Department, Rohini College of Engineering and Technology. Here we are going to discuss about the subject computer architecture and organization. From this, you are going to discuss about that pipelining hazards. Pipelining is not suitable for all kinds of instructions. When some instructions are executed in pipelining, they can stall the pipeline or flush it totally. This type of problems caused during pipelining is called pipelining hazards. In this, we are having three types of hazards. First one is the structural hazard, data hazards, as a control hazard. Structural hazard arises due to the resource conflict in the pipeline. Data hazard that occur when an instruction depends on the result of previous instruction and that result of instruction has not yet been computed. So in this four type of dependency, the first one is the read after write, write after read, write after write, read after read. Next one is the control hazard. Control hazard occurs during the transfer of control instructions such as branch, call, jump, etc. On many instruction architectures, the processor will not know the target address of these instructions when it needs to insert the new instructions into the pipeline. Performance evolution factor of pipelining. So in this, the performance, its main thing is the latency, efficiency, throughput. Benefits of pipelining: it increases instruction throughput, better utilization of processor components, efficient for repetitive task or streaming data. Disadvantages of pipelining: designing of the pipeline processor is complex. The problem of hazard for branch instructions increases with the longer pipeline. It is difficult to predict the throughput of the pipeline processor. Dependencies in the pipeline processor: structural dependency, control dependency, as well as the data dependency. In this, first we have you have to know about stall. A stall is a cycle in the pipeline without new input. Structural dependency: this dependency arises due to the resources conflict in the pipeline. So this one is the main instruction execution. So in this scenario, we can see in cycle 4, instructions 1 as well as 2 are trying to access same resource memory, so which introduces a resource conflict. To avoid this problem, you have to keep the instruction on wait until the required resource is available. This wait will introduce stalls in the pipeline. So solution of structural latency: to minimize structural dependency stalls in the pipeline, we have to use hardware mechanism for renaming. So renaming, according to the renaming, we divide the memory into two different modules used to store the instruction, and they are separately called code memory and data memory respectively. Code memory will contain all the instructions and data memory will contain all the operands that are required for the instructions. So this is the data will be explained about all the stalls and execution. So control dependency: this type of dependency occurs during the data transfer control instructions such as branch, call, jump, etc. On many instructions architectures, the processor will not know the target address of the instructions when it needs to insert the new instruction into the pipeline. Due to this, unwanted instructions are fed into the pipeline. Consider the following execution of the program. So this is the thing explained about this control dependency. Data hazards. Data hazards occur when instructions that exhibit data dependence modify data in different stages of pipelining. Hazards cause delays in the dependencies. In this, we are having the types of data hazards: read after write, as well as write after read, write after write, as well as read after read. Everything will be comes under this dependencies.